guys, in this right here, solving equations having, we've already talked about what like terms are. So we just got done saying, you know what, the having like terms part meant like the 2t plus what? Well, 3t. What's that going to equal again, gang? 5t. So anything that's had like terms in it, we're going to go ahead and simplify. So when we start looking at this section today of solving equations having like terms, we want to remember what it means to combine like terms first, okay? And then secondly, we're going to have situations where the equations are now going to start inserting some parentheses. And in the past, we've talked about a property that would get rid of parentheses. So as an example, suppose I had 3 times 2x minus 5, like this. Guys, what's the name of the property that allows me to rewrite an equivalent expression for that without parentheses?
Distributive.
Distributive. So if I was to distribute right here, what's the 3 times the 2x going to get you? 3 times 2x. I know it's Monday. Here we go, though.
6x.
6x. There we go. And then how about the 3 times the minus 5 here when I distribute that? How much? So minus 15. So an equivalent expression to this mess up here with parentheses would be 6x minus 15 without parentheses, right? So 2 questions here before we start moving. Do you guys remember how to distribute? Number 1. Okay,
Yeah.
Lots of heads shaking. All right. And then how about combining like terms right here? Okay, and combining like terms? All right, so let's go ahead and take a look at these examples here in our notes. I think 2 things I want to point out. Before I start looking at this example that we're going to apply to real life, I want you to jump down here to the bottom. And I want you to highlight these rules down here, so, or refer to them. But these rules are going to be really important to follow, okay? This is going to be the big idea for the day, so you're going to want to refer to this part down here at the bottom an awful lot today, okay? So we'll talk about rules to solving equations here in a second. We already have a lot of rules in place for 1-step equations and 2-step equations. Guess what, gang? You've done 1-step equations and 2-step equations. What do you think is beyond 2-step equations? 3 and 4 and maybe even some more. I like that. 3 and 4 and maybe some more. Right, Maddie? Oh, good.
No.
It could have been a rap. I could have said there's a
Or no.
1-step equation and a 2. Now we're on to 3, a 4, and maybe even some more. You like that?
I like
Oh.
John's.
Okay, let's rock and roll here. Yeah, I'm not a rapper, I'm a rocker.
My dad is a blueser.
What I would like to do
Oh.
is set a goal to solve equations with parentheses and like terms. So we're going to look at doing that today. So to kind of get an idea where this takes place here, I've got a baseball game example up here. Fitting since World Series Game 1 is tomorrow. I need a volunteer to read this situation for me. Who would like to do that?
What?
Maddie, you want to read that, please?
Yeah.
All right.
Baseball game. A group of 5 students are going to a baseball game. Tickets for the game cost $12 each, or $60 for the group. The group also wants to eat at the game. Hot dogs cost $2.75 each, and bottled water costs $1.25 each. The group has a total budget of
$76, right?
Or $76.
There you go.
If the group buys the same number of hot dogs and bottles of water, how many can they afford?
Okay,
To buy?
what I would really like to do is model this with an equation in terms of what's going on, okay? So, the situation is this. There's 5 of us going to the game, right? Each ticket was $12. So, totally the group is going to pay how much money here, guys? How much money is the group going to pay totally? $76. Now, it also says the group wants to eat and drink something at the game. It said that hot dogs are how much? Man, I want to go to this ballpark. $2.75 for a hot dog? That's a robbery. And $1.25 for water. It says the group has a total budget of how much money? $76. What's most important in this problem is the following, is this last sentence. It says if the group wants to buy the same number of hot dogs as they do bottles of water. So if I buy 7 hot dogs, what's this implying in that problem? If I buy 7 hot dogs, that's implying that you're also buying 7 bottles of water. Number of bottles of water. So there's 1 water for each hot dog, right?
Yeah.
Okay? Don't tell that to Joey Chestnut. He might take you seriously. You guys know who Joey Chestnut is? The hot dog eating guy on the 4th of July on
Oh, that
ESPN.
dude.
Yeah. What did he eat? Like 62 hot dogs in a
I think he
10-minute
would have
session?
grown up by then.
I don't like hot dogs. So I don't
Oh,
They would have
You are
grown up
so
by the
weird.
hot dogs? Ooh,
they're good.
37 hot dogs.
do
We
you know
made-
what they're made of?
We made hot dogs. Oh yeah, but we made hot dogs. We split them Saturday night. The girls love them. We split them in half and put cheese and stuff in there, and then we wrap them up in a little crescent roll and bake them. And
Oh, pigs in the
Pigs in the
blanket.
blanket.
I
You bet.
had those last night.
Yeah, they were good. All right. Well, anyhow, what I want to imply here is the following,
You're
gang.
a weird, weird child.
Do we know how many? Do we know how many bottles of water and hot dogs we're gonna buy? Do we know how many we're gonna buy right off the bat? We don't. That's what we're trying to find, right? So in this problem, let's do this. Let's let x equal the number of hot dogs. Let's also let's let x equal the number of what else? Bottles of what?
Water.
Yeah. Okay, if I buy 7 hot dogs, that means in this problem we're buying 7 hot dogs. Or if I buy 4 bottles of water, that means we're buying 4 hot dogs, right? We're buying the same number of each in this problem. Do you guys agree with the way that's worded up there? Okay. Well, here's the situation. Guys, if hot dogs cost how much a piece in this problem? $2.75. If I buy 3 hot dogs, how much money am I going to spend, or how would you figure out the amount of money spent for 3 hot dogs?
What, how many
You
people are there?
multiply it.
Well, it's 5 in a group, okay, but that's irrelevant, okay? Yeah, you would take 275 times 3, right?
And
Okay.
that is 825.
Okay. Well, here's the situation. How many hot dogs are we buying? Miller just said, you know what, take the number of hot dogs times the price, I'll tell you the cost for hot dogs, right? Okay, watch what happens here. What is the cost per hot dog?
275.
So I'm going to take 275 times what here? So 275 times x is going to represent the cost I have in hot dogs. Would you guys agree with that? Okay. To the cost in hot dogs, we're also adding a cost in what else? Cost in water, right?
Yes.
Okay. What's each water cost? What are you going to multiply that by to figure out total cost in water? So I'm going to add 1.25 times x. Now, we also had some other expenses in the total budget up there. What was another expense for us if we weren't, you know, just to get into the game, what that cost the whole group? $60, right? Okay. So I'm going to say this mess right here. Let's just kind of talk about what this mess is. I have a cost for hot dogs right here. That's this expression, isn't it? 275x. Plus a cost in water, which is 125x. Plus this $60 cost was the cost for the tickets for everybody to get in, right? Okay. What was our total budget? What does this have to add up to if we spent our total budget? What was the total budget in this problem? $76. So what's this mess going to add up to? Price of hot dogs plus price of water plus price of tickets equals a total budget of how much? Okay. That's the equation that would model what's going on here. Question is, how many hot dogs and bottles of water are you buying? Same for each. Right? Guys, does this look like more than a two-step equation?
Yes.
Okay. Down below, I told you to highlight stuff right here for rules of solving equations. If you can follow this step by step, understand what you're doing step by step in these rules for solving equations, this will be a piece of cake. Okay? What's the first rule say to solve equations that we're going to start looking at today?
Distribute to get rid of all parentheses.
We're going to try and distribute to get rid of all parentheses. Well, here's the first question. The way I've set this problem up, are there any parentheses? Are there any parentheses? No, there weren't any, so we're good here. Check that off each time. Okay, second thing then says combine like terms. Now I should say combine like terms on each side. So when I say combine like terms on each side, here's what I'm really
Would
doing.
you rewrite that?
Yeah, you can. Here's what I'm talking about. When I say on each side, I'm saying look at the left-hand side of the equation, look at the right-hand side of the equation. Maybe this will help. Let me try and get fancy with this tool. Hang on a second. This is kind of fun. Oh, it's magic. There's the equal sign right there, right? So isn't this the left part of the equation? Okay. Guys, on the left side, would there be any terms I can combine or put together?
Yeah.
What could you put together on the left side?
275 and 125.
These would combine right here. I've got an X here and an X here, so I could combine those, couldn't I?
Yes.
What's that gonna add up to? $2.75 and $1.25.
$4.
4x. I could call this part 4x. So this is now 4x plus what, gang? Plus what still? This part's my 4x, isn't it?
60.
4x plus 60. What's this still going to equal over here, gang? What's it still going to equal on the right then? Whoops, I forgot a 0, didn't I? What's that going to equal on the right still?
76.
76. 76 is the only term on the right side, therefore no combining on the right side, right? Guys, after you've gone ahead and taken care of the step 2, and these are really the only 2 things that are going to be new for us today. Doesn't that look like an equation that we dealt with in the last section?
Yeah.
What are you going to do next with this problem now?
Minus 60.
You're going to subtract the 60.
Where's the
Subtract 60. Okay. So what are you going to have? Well, you'd have 4x equals what? What is 76 minus 60? 16. Now what are you going to do with that expression at this point?
Divided by 4.
Oh my gosh, by the way, step 3 was that part, undo addition or subtraction, right?
Yep.
We know how to do that. And then what's the final step that we're looking at today?
You're going to divide it by 4.
Undo some multiplication or division. Okay? So here's the dealio. When I undo the division, when I undo the multiplication by dividing, what do I get my x value to be?
4.
X is equal to 4. Hey, quick question. What's that x equal to 4 implying then in this situation?
4 hot dogs. 4 water.
So here's the deal. If there was 5 of us, I need 4 people to come up here and stand with me. Anybody, there's 1.
2.
Here's 2. 2 more. Come on. 2 more. Come on, Maddie. John's coming.
Yes.
All right. Okay, so we're at the ball game. Okay. Let's just pretend the Twins are in the World Series. Hey, they won the World Championship in 1987. I got to go to Game 6 of the World 87 World Series.
Oh, that's cool.
Yep, I was 12 years old. Okay.
Wow.
And I also they won the World Series in 1991. Okay. But so we're pretending we're at the World Series. It's the first inning. We're gonna do the wave first. Start the wave. Do it. Ooh. All right. Okay. Hey, are you guys hungry? There's 5 of us here, right?
Yeah.
Hey, hey, I've only got 16 bucks to run downstairs with. I'm gonna run downstairs. Those costs right here. I'm gonna come back with what? 4 hot dogs and 4 waters. Is everybody gonna get a hot dog?
Yes.
No?
No. There's only 4 of them, right?
Yes.
Is everybody gonna get a bottle of water?
No.
No. Might have to be some sharing going on here.
Yeah, like
I don't
putting on
share.
like
Makes sense?
Maddie does.
All
I
right.
don't share.
You guys get what's going on here?
Especially when it's
Should
big.
have bought the Homer hanky today. We could have really done it. Okay, have a seat. Thank you.
Bye.
All right. Questions about this right here?
You too, John.
Questions about that? All right, let's run on to the second page here. Let's start looking at some examples. Let's start practicing this. Okay, guys, so in our rules right there, in our rules that are new today, the top ones say, first of all, you need to get rid of what if you're going to solve these equations? What do we have to get out of the problem? Parentheses. And now, what I'll also tell you is this. It may be possible that some of these problems you're going to have to distribute more than once. Okay, so there might be multiple sets of parentheses. Then the second one that's new to us, after we've gotten rid of parentheses, you have to combine terms on either side of the equal sign. So let's jump into this. Guys, this first example I have here to solve. In that first example, I'll start and say, are there any parentheses that we've got to get rid of first? Okay, on the right side there are. So I'm going to set this up as negative 24 equals Okay, gang, help me distribute. What's the 6 times the 2 gonna get you?
Well, hey, Mr. Parson, I can't see. Thanks.
Negative 24 is equal to 12, and then I've also got to take this 6 times what else in there?
X.
Okay, so 6 times x, and is this going to be minus 6x or plus 6x?
Minus.
Everybody agree with what I've got?
Yeah.
Okay, now, if you recall on the last section, I don't really care for the way this is written. Would you guys buy that? I like having my x's where?
Over here.
Out in the front. Is it okay for me to take what's on the left side and the right side and switch them around?
Yeah.
So I can take what's here and move it to the left, right?
Yeah.
And I can take what's here and move it to the right, can I? Guys agree that that's okay to do? Is that okay to do?
Yes.
Okay, now, do I really want my negative 6x here?
Nope.
Okay, some of you might say, I know what to do from here, and that's totally okay, all right? I just like to move stuff around so it's a little easier for me to think about patterns that we've talked about in the past. How might I rewrite this equation now?
Well, I got you.
Negative 6x
You stole my moment.
plus 12 equals negative 24. You can be the echo of thunder that comes. She can be the lightning, you can be the thunder.
No, she is not. No, she needs to learn how to shut her trap.
Money, stop.
Well, if she closes her trap, that means she caught something, and that's not going to be good for somebody. So,
Did
Agree
you
with
just
that?
say gone?
Huh?
You just say gonna?
yeah, gonna.
Gonna?
I like gonna. I like that word. Okay.
But that's my word.
Hey, what's my next step? And then maybe I should ask the question, after I've gotten rid of parentheses, are there any terms on the left side that combine? The answer is,
Nah.
and on the right side, any combine? This is a simple 2-step equation to this point, isn't it?
See,
So what am I going to subtract from both sides now?
20 or 12.
Minus a 12, minus a 12. So as I do this, 12 would cancel there. We've got negative 6x equal to negative 36 now, don't you? So how about negative 36 divided by negative 6? What's that going to get you? Positive 6. So my x value is 6. Very good. All right. Let's take a look at number 2 quickly.
Yes, let's.
Guys, number 2, same questions. I'm going to go right through the order. And again, I'm following this menu right down at the bottom here. You know, step 1, are there parentheses? Step 2, can I combine stuff on either side? Step 3 and step 4 are basically parts of the section that we looked at in 3.1. So on this second page right here, problem number 2, are there parentheses to deal with?
Yeah.
Yeah. Oops.
Wait,
Yeah.
if I did it like, if I didn't rewrite it and just had it the way that it was originally,
That's fine. You don't.
I got -2 for the
What did you do here if you didn't rewrite it?
I just did, so it was -24 equals 12 minus 6x.
Okay.
I put plus 12 on both sides.
Careful. The way it's written right here, what kind of 12 is that already? Positive. So that's a positive 12 right here, Taryn. How are you going to get rid of a positive value? Again, positive 12 is like addition of 12, right? So if you have addition of 12 right here, how are you going to do that addition? So you should, instead of adding 12 to both sides, you should have,
Well, because it already says 12 minus 6.
I understand that, but is that minus sign before the 12 or after the 12 that you're working with?
After.
You want to look at the sign that's directly before those numbers, not the one that's after. Okay, and even though there's no sign, in front of the 12, it's assumed it's positive, right?
Okay, so if
You
it
look
were
at-
6x minus 12, then it would be different.
Right. Okay. Understand?
Yeah.
Okay. All right, let's talk in the second one, guys. What do you have to distribute to your parentheses? What value? What value are you bringing into parentheses here? What value are you bringing into parentheses here?
Oh,
Negative 2, right? All right, so I'm going to start by saying negative 2 times 7. What is that? Negative 14.
Minus.
Be very careful on the next part when you distribute. You have -2 times -4x, don't
So
you?
it's gonna be addition, right?
So you're going to add 8x here. A negative times negative is a positive 8x. So plus 8x equals 10. Let's just maybe take Taryn's approach to this and say, let's say we don't want to rewrite this. All right? There are not terms on either side to combine, so this is now down to a two-step equation. I don't like this -14 out here. So what should I do to get rid of that? It's negative, so you're going to add 14 to both sides then, right?
Yeah.
Okay, good. Plus 14, plus 14. All right, roll on. What are the 14s on the left going to do to each other?
Can go on.
Yep, gone. 8x equals what value on the right? What's that sum on the right? 10 and 14.
24.
24. Okay. So I'm looking at taking 24 and dividing by what value?
8.
And what's my solution here?
3.
So your x value will be
You owe me a soda.
3.
Well, we said something at the same time.
Okay. How you guys feeling? Getting there? If there's parentheses, can you have it? The answer is no. All right. Number 3 is going to be a good one for us to look at. So number 3, might want to choose to do this real quickly. Might want to do this. Make a nice little star.
Again with your star.
Okay. It's pretty good. Not perfect, but it's pretty good.
You mean it is perfect?
Okay, gang, this one here is kind of tough, all right? But this is a good problem because it ties in all 4 steps together. Okay, first of all, are there parentheses?
What?
Are there parentheses here?
Yeah.
Okay, what number is directly in front of parentheses?
The 4.
What kind of 4 is that?
And negative.
Go ahead and highlight my -4 right there. Because we're going to end up distributing that. Now, out in front of the distribution, don't I have a term 6x?
Yes.
C.
Is that 6x in parentheses?
No.
Okay, so what I'm going to tell you to do with this right off the beginning is just bring that straight down. Don't worry about that, but carry it down there, okay? That's just part of the problem. Now, I've brought that down. For the rest of the problem right here, I have to distribute -4 to that quantity x minus 1, don't I?
Yes.
So how about the -4 times the x? What's that going to get you?
-4.
So after the 6x, what am I going to write, Taryn? Minus. Good. Then I also need to distribute that -4 to a -1. So what's going to come in after that? Got to distribute -4 to -1. Negative times a negative. Shout it out, peeps.
-4.
Not negative. Plus 4, right? Good. Parentheses are gone. Step 1, right? Step 2, look at both sides. Left side, anything I can put together to simplify that side? How about 6x minus 4x? What is this part right here? How much? 2x. So this expression on the left can be simplified as 2x plus what still? Well, plus 4. And then that would equal 14. That's my only term on the right. Oh boy. I like it when I get here because we know what to do when we get here, don't we? Right?
Yeah.
Subtract the 4, divide by 2. So subtract the 4. You guys agree? What's 2x going to equal from this then? What's 2x going to equal? What is 14 minus 4? 10. Go 10 divided by 2. Where am I?
5.
X is 5. Whew. Didn't that involve all the steps? Did we have to distribute? Yes. Did we have to combine like terms? Yes. Did we undo addition, subtraction? Oh my gosh, that's the most ugly looking 5 I've ever seen in my life. Ooh.
Funny.
Did we have to undo addition, subtraction before that 5 intervened in my speech?
Well, we have work to do.
Yes. Did we have to undo multiplication, division? Yes. They were all there, weren't they?
Yes.
That part we highlighted in the first page, important or not important? Okay, let's look at another example. Now I'm going to turn you loose on trying some of these, and we'll get you up to the board to try this. Oh my goodness, I killed a 34 right there, didn't I? Okay, kiddos, here we go. I'm going to bring that negative 4x straight down. Okay, you guys tell me about the distribution part. What am I going to write after negative 4x? Raise your hand, please. What am I going to write after negative 4x?
Plus 7.
Well, I don't want to do this. We got to distribute, don't we?
Oh yeah. So
14 what? Plus 14x. What's after that? 7 times what, gang?
6.
What kind of 6? Negative 6. So subtract how much now? What's 7 times 6?
42.
42. What's that equal on the right?
34.
Okay, so parentheses are gone. Now where to go? Where do I go now?
Negative 4x. 14x.
Okay, so what's 14x and a negative 4x going to combine to? 10x. So I've got 10x minus 42 equal to 34. Good. Now what? Now what?
Add 42.
Good,
both
John.
sides.
Add 42. I'm running out of room. That's okay. I'll squeeze it in over here. So when I add 42, everybody, 42s are going to cancel here. I have 10x equal, let's see, what is 34 plus 42? 76. So in your calculator, or just move your decimal 1 to the left since you're dividing by 10, what is 76 divided by 10 going to get me? How much, Chelsea? 7.6 is my solution here. Okay. I know this is kind of sloppy right here, but I think if you were paying attention, I understand how I got there. Are all numbers going to look perfectly whole or be integers when you're done?
No.
You may end up with some decimals. You may end up with some ugly decimals possibly. All right. Again, process, 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 process. I don't care about, hey, what's the answer? I care about what's your process to get that answer. Okay. Questions about those 4 examples that I've done? Please take about, I don't know, I'm going to give you about 3 to 5 minutes to process these. I want you to try these 4 problems on your own. And we'll get some people up here to try these. So, if you get stuck, check with your peers around you, talk each other through it if you get stuck. But when you've got all 4 answers, check with a neighbor, see if you agree. And again, I always tell you, if you disagree, talk about why you disagree, okay? Sometimes your best learnings comes from the mistakes you learn. And trust me, I've made a lot of them. First mistake was becoming a Viking fan.
Yeah.
Hey, you have no room to
I know.
talk.
The whole thing. Yeah.
It was not a good football.
No, it was.
No.
It was for me. I love the Miami Dolphins.
Oh,
For
shut up,
donkeys.
Jimmy.
Screw you.
All right, math.
Watch your mouth.
Oh, math.
Miami Dolphins said
I won't talk any more football.
I
Yeah.
don't care.
You guys should be on the field, not in the classroom. Woo! Here we go. Get them done. Oh yeah, we're recording this. You bet. This will be a good one to watch or listen to, if you will. Okay. Get rolling, kiddos. Are you recording this? Love it, love it, love it. Hey, if we can't have fun in here, what's the point,
No.
right? If we can't have fun in here, what's the point, right?
Are those updated grades?
Very updated, yes. I think I put them up there Friday mornings.
This is a good book.
Again, if you get stuck, check with someone around you, okay, guys?
I like it. I like it a little.
Oh, I love Scout.
Dude, I think it needs like romance though.
It's not romance.
I know. Which like makes me mad.
I know. But it's really good.
For the most part, it is. Yeah.
I kind of want to read that. I have so much writing.
Yeah.
guys, as you're working on these, I'll remind you one more time, if you have, that test you wanna think about retaking, you've got till Friday to do that, you know that, right? And again, I think we had a conference with everybody on Friday, and I told you whether I think you should or maybe you didn't need to take it, but, just be thinking about that. If you're gonna retake that test, it needs to be done by Friday during, study hall or before school or after school, alright?
So now you need to get this one. Okay, I can't find my exit date. There's no other X's to do that. So we might have to do this. 15. That's what I need to do. Okay. 15 plus this.
Again, when you've got them, check with someone around you, see if you agree, okay?
Ready? Go.
Positive 4Y. So instead of having one Y, that should be a, they're both positive, that would be 7Y, wouldn't it? Yeah, because the plus sign should have moved with it, so it should be 7Y minus 14 equals 28, okay? So write 7Y minus 14 equals 28, and then work with it from there, alright? Give me a show of hands. How many of you need more time?
I do.
Okay, give me about another minute here. And we'll work together as a group. I'm gonna have some kids come up to the board and do these here. Who wants to do the first one for me? Oh, don't be shy. Anybody want the first one?
I'll take the second one.
You got the first one, Chelsea? Thank you, Chelsea. Chelsea, rock and roll. Do you see the little like magnifying glass with a plus up there?
Right here?
Yeah, there or else up top maybe. You reach it? There you go. Ooh, you had it. Okay, why don't you scroll to the left and put your work on that one. Alright, rock and roll.
Put it up.
There you go.
Can I rewrite it?
Yeah, if you want to rewrite it, you bet. Tell me what you're doing with this, alright?
Okay, so I'm just rewriting it.
Okay, so you're gonna go 5 times. You're gonna move the x to the left, it looks like, right?
What?
Move an x to the other side. Or the part with the x to the, I'll be quiet, you just go. My wife says I talk too much. Do you believe her?
Yes.
What?
No. I say you talk too little.
So then you do
Okay.
15 times 3. I mean, if it's like that. 5
Yeah,
times
yours.
3.
5 times 3, okay, good.
But seriously, all you can see
Minus.
is what's reading and stuff like.
Everybody agree so far with Chelsea?
Yes.
I think she's doing an awesome job there. Okay, timeout. Chelsea, look at your 5x in the preceding line.
Negative.
And then what kind of 15 did you have? Okay, there, I like that rewrite better. Good save. Alright, now you may disagree with what you have on paper, I'll talk you through it, okay? What are you gonna do next?
Minus.
Okay? Okay, I'll tell you on the left, you're gonna end up with negative 5x, right? Why don't you make a squiggly line just to the right of all the work you've done so far.
Oh, I wanna go.
So you're gonna have negative 5x equals. Okay, if you went shopping and you spent $20 and then spent 15, that'd be like a minus minus, right? How much money have you spent totally?
Wait, what?
You spent $20 and you spent $15. How much have you spent totally?
35.
So you're down $35. So what value should you have on the right?
Negative 30.
There you go, kiddo. Alright, so you're negative 35 divided by negative 5. What's your solution?
7.
Very good. Very good. Everybody agree? Nice work. Chelsea, pick someone to do the second one for me, please. I'll help you. Karen, you got it? Karen, you probably need to scroll it to the right a little bit, okay, kiddo? Alright, Taryn, talk me through this. I don't get any of it.
Okay. So you'll combine 4y and 3y.
So both are positive, right? And what are you going to call that?
7y.
Everybody agree combining like terms to get 7y so far? Allie, did you catch that there then?
Yeah, I got it.
Excellent save. Alright, what's after the 7y?
Plus negative 14.
Minus 14, yep.
I probably got my answer wrong because I did plus 9.
That's okay, we'll talk through it. What's that still equal to on the right then?
28.
Good. Alright, Taryn, you're on a roll.
So then,
Why don't you put the sheet aside and look at the problem you're on now, and if you got any numbers to crunch, I'll crunch them for you. What are you gonna do?
we'll add 14.
Okay?
So
42.
then 5 by 7.
Excellent. I think the thing I'm most proud of with you guys this year is the amount of work you've shown on this stuff. 42 divided 7, helper.
6.
Excellent work, gang. That's awesome. Very good. First two are great.
Okay.
You can pick someone to do the third one, yeah. Candace, you'll have to slide that back to the left, alright?
Oh, I still got the right answer. This person.
I'm sorry?
On mine, I still got the right answer.
Okay, good deal. Alright, Candace, run me through it.
First, you have to do the parentheses.
Okay, so you're going to distribute. Careful on your distribution. Let's see if she catches it. Candace, why are you changing that minus sign to a plus? You're gonna take what times what?
-3 times -20.
Yep, so a negative times a negative, right? All right.
Then I add 18.
Okay.
Then I divide it.
And what did you come up with? Just click anywhere, don't, yeah, there you
Wait,
go. Oops.
huh?
Click that down. There you go.
What
I'm at 5 there. Good. Good. All right. Hey, in the essence of time, I'll run through the last one. That's excellent. Thank you, Candace. Any questions about this one right here?
Yeah, wow.
Yeah.
Wouldn't it be 8 minus 18?
Well, again, what kind of 18 did she have here?
Oh.
Has nothing to do with the sign behind the 18. It's what precedes it, right? What kind of sign was there? So you got to. All right.
I don't like this.
You have got to know. You don't hate this.
Yeah, I hate
Oh, come on. There's only 3 things you should not like.
math.
4, actually. Okay. All right, guys, real quickly. What value is right in front of parentheses on this last one? By the way, what did you guys get for a solution on this last one? I'm curious.
8.
8? I'm hearing 8. Let's just confirm that quickly. I'm going to bring the 5x straight down. Okay. How about the -2 times x? Wouldn't that be -2x when I distribute? In agreement. How about -2 times -3? What would I put after that? Plus what? Isn't it plus 6? A negative times a negative right here. Everybody agree?
Yes.
Okay. All right. So this last one right here. How about 5x minus 2x? What do you have there? Isn't that 3x? What are you going to subtract from both sides? So what is 30 minus 6? So I have 3x equals 24, right? Everybody okay with that step? All right. 24 divide 3, where am I? What's my solution? What's my solution here? All right, good. Okay. Guys, that's a lot of stuff in a short amount of time. And I think I'll just get you a short assignment. I think the quick quiz is attached, right?
Yeah.
Save that. Just bring that tomorrow. We'll get that done first thing in class tomorrow. So just put that away. You're going to have some time to work tomorrow on stuff.
Oh, just forget it. I don't have time for this. I'll just rip these up and throw them away. What? I don't have time for this. I have to work.
All right. Write this down,
I need
please.
some fresh notes.
Write this down. Page 805.
Okay, already. Good. I wrote it on my planner.
All right, 9 through 17.
Page 105.
805 is where it's at. I'll get out of the way here in a second. Let's put down due Wednesday for this, all right?
What's the date?
Today is the 20th.
October?
October 20th, yep. Okay, so page 805, problems 9 through 17. I want them by Wednesday.
I won't be here Wednesday.
Okay. Why don't you remind me tomorrow and I'll see if I can't dig some stuff up for you, have it ready for you, okay?
It's Wednesday?
Yeah.
Okay, but you'll show up. Just have it see you when you get
No, I'm going, I'm coming into early bird only because I have to. And then I'm gonna leave right after.
Oh my gosh.
You
Chair
messed
there.
me up.
Sorry.